Welcome to the series of run-throughs through the O-Level papers. Today we are looking at the Science Chemistry October-November paper from 2023. Right, so paper 1 would be the multiple choice. Okay, so let's get into it. Okay, for each question, I have labeled the topic from which it comes from, so that if you have any more questions or doubts, you will know which topic that you will need to revise, for you to improve yourself in that particular topic. Alright, so the first one, a titration is carried out to measure the volume of hydrochloric acid needed to neutralize sodium hydroxide, and we have 25 cm³ of aqueous sodium hydroxide, of which hydrochloric acid is then added. So this is your titration experiment, and for titration experiment actually it is using burette and pipette. So actually from this question you can really eliminate B and D, right, because titration uses burette and pipette. So we are making sodium hydroxide constant at 25.0, and then we are varying the amount of acid that we are adding, to find out the exact amount. That's the main idea behind titration. To find out by fixing one of the reagents, then we add another reagent using the burette. We can find out the exact amounts that we require for neutralization to take place. So with that, this is the one using burette, and this is using pipette, your 25.0 cm³ pipette. So the answer is C. Next we have a QA question. Alright, so we have various tests using 4 bottles A to B. But what we have is ammonium chloride. Now which one is ammonium chloride? Testing for dilute hydrochloric acid. And since it's a solution and it's not a solid, then that means we don't have metals. We have compounds dissolved inside water. So if there is any fizzing or any effervescence or bubbles produced, it will be due to a carbonate. So this is your test for carbonate. Warm with aqueous sodium hydroxide. This is your cation test. Adding nitric acid followed by silver nitrate. Please remember, when you add a silver solution, you are testing for chloride. Alright, so since adding hydrochloric acid is a test for carbonate and we are finding ammonium chloride, there shouldn't be any fizzing, so no reaction would be correct. Next, the cation test. Our cation is ammonium, and when you warm ammonium salts with sodium hydroxide, ammonia gas is produced. Excuse me. And when ammonia gas is produced, it will turn then red litmus paper blue. Alright, so we have these two. Alright, this is already out. Next, silver nitrate, the test for chloride, and since ammonium chloride does contain chloride, you will get a white precipitate. So the answer is B. Still quite straightforward. Okay, next we have the third question on kinetic particle theory. Alright, so we increase the temperature of a sample of gas. Right, so what will happen to the particles? Okay, when you increase the temperature, okay, so particles move faster. Alright, this is also applicable for your rate of reaction topic. So when you increase temperature, the speed is faster, and it makes logical sense. If they are moving faster, they will collide more often. Yeah, so rate of collision of gas particles also increase. Answer is D. Okay, fourth question, atomic structure. Okay, so key points here is, in an atom, number of protons is equal to number of electrons. Okay, and in an ion, okay, number of protons is not equal to the number of electrons, because in an ion you have lost or gained electrons. So maybe I'll write here. In atom, okay, number of protons equals electrons. Okay. In ions, number of protons is not equal to electrons. Okay, because in the ion, the electrons has been gained or lost. Okay, so therefore they are no longer equal. Alright, so aluminium, okay, there's no charge here, therefore it's an atom. Okay, since there are 13 electrons here, this will also be 13. Okay, next I have aluminium 3+. Okay, please remember, if your ion is positive, that means it has lost electrons. So therefore it has lost 3 electrons. So originally it would have 13, because the atom will have the same number of electrons as the number of protons. So when you lose 3 electrons, it should be 10. Okay, sulfur 16. Okay, alright, we don't know the mass number for this. Okay, so actually it can be any number. Alright, within reason. Okay, for an isotope of sulfur. Okay, yeah, so maybe most likely it will be close to 32. Okay, in your periodic table, the mass number for sulfur, sorry, let me correct that. Okay, in the periodic table, the relative atomic mass for sulfur is 32. So the average of all the isotopes, okay, with percentages, okay, is 32. So I would expect it to be around 16. Okay, but there is no way for me to actually tell, okay, if I don't know what's the actual mass number for this particular particle or isotope. Yeah, so I can't give anything yet. Okay, alright, but let's look at this one. Okay, so sulfide. Okay, by the way, important. Okay, this is your sulfide ion. Okay, not to be confused with sulfate ion. Alright, so S2 minus is your sulfide ion. So since it is 2 minus, okay, that means it has gained 2 electrons. So originally the atom will have 16 protons and 16 electrons. Okay, but since it's an ion and it's 2 negative or 2 minus, it has gained 2 electrons. So this will be 18. Alright, so looking at this, we have 13, 10, 18. Alright, as I mentioned, okay. Alright, I would think that Y would be 16 or around 16. Okay, because for isotopes, the number of electrons, the number of neutrons, okay, should be around the same value. Okay, yeah, so actually any of these numbers seems fine. Alright, yeah, so because the average of them, I should get 32. Yeah, so the answer is D. Alright, next. Okay, this question, fifth question, test on two concepts, a formula and equation, and also ionic bonding. Right, so it's an ionic compound. Okay, so what does the melting point of gallium sulfide would be, and what's the formula? Okay, so the melting point should be high. Okay, and this is Ga2S3, and as we've seen, sulfide will form 2 minus, okay, because it's in group 16, and gallium is actually in group 13. Yeah, so actually gallium, okay, group 13, okay, therefore it should form Ga3 plus, okay, and sulfur is in group 16, therefore it should form sulfide S2 minus. Okay, this is one way to do it. Okay, or the other way is to work it out yourself. Okay, alright, but you still need to know that sulfur makes 2 minus. Alright, yeah, so I have Ga2S3. So what does this mean? I have 2 Gas and 3 sulfur ions. Alright, okay, and the charges of all the positive ions and all the negative ions must balance. Okay, whatever electrons are lost from the metal ions, okay, should be taken in by the atoms of the non-metals. Alright, yeah, so it must be balanced. Okay, if it was A, 2 plus and 2 plus, and this is 3 minus 3 minus 3 minus, the total charges would be 4 plus positive and 6 minus negative. Sorry, wrong, 9 minus negative. Okay, yeah, so okay, alright, the charges are not balanced. Okay, therefore this is wrong. Okay, therefore the correct one should be 3 plus 3 plus 2 minus 2 minus 2 minus, and therefore you will get 6 plus and 6 minus. The charges are balanced. Okay, therefore the answer is B. Okay, another method which I don't quite like to teach, okay, because it can cause confusion, is your cross method. Okay, so this one, if you reverse the cross, okay, you will get 3 plus and 2 minus. Okay, 6th question. Okay, alright, so relative molecular mass for ammonium carbonate in this case. Alright, so I have NH4 to CO3. Okay, so you're gonna look at the relative atomic masses for each atom. Alright, so that will be the bigger number in the periodic table. So the MR, okay, I like to use the formula to work out the MR. So nitrogen is 14, okay, hydrogen is 1, okay, but there is 4 of them, so times 4, then I close my bracket. There are 2 sets of NH4. Alright, next I will add my carbon, 1 carbon, and oxygen is 16, but there are 3 of them. So let's work it out. Okay, and I get 96. Okay, right. Okay, I like to teach my students this method, okay, because it makes use of the formula itself. Okay, yeah, so I will reduce errors, for example, okay, forgetting that there is 2 nitrogen, or you accidentally multiplying 4 times 2 becomes 6, or something like that. Yeah, that's how you can get numbers like 80 or 94, okay, where it's off, okay, by 16 or by 2, right, because you did not multiply correctly. Yeah. Okay, so 27. Okay, we have the stoichiometry question. Acid rain contains sulfuric acid. Alright, which is this one. So we have 25 cm³ of acid rain. Okay, neutralized by 28 cm³ of 0.25 sodium hydroxide. Okay, notice I did not highlight the coefficient. Okay, the coefficient is to balance the equation and also tells you the mole ratio of the reactants and particles in the reaction. It is not part of the formula for sodium hydroxide. Okay, sodium hydroxide, okay, is NaOH. Yeah, let me increase this. Right, so what's the concentration of sulfuric acid? Alright, luckily there's some space below here. Alright, so okay, showing you the method that I teach my students. Okay, which we call the junction method. Alright, because in any stoichiometry question, okay, alright, from the from the starting point to the ending point of what you want to find, okay, it must always change to mole first. Yeah, so the first junction, okay, in your journey, alright, should always be moles first. Alright, so let's write, okay, the info that we are given. So we have 25 cm³, okay, but please change to dm³. Okay, alright, and this one we are given 0.028 dm³. Okay, we are also given 0.5 mole per dm³. Okay, alright, so this is concentration, right? And we have aqueous solutions of acid and alkaline, in this case sodium hydroxide. Alright, so this is not your gas formula, okay, where it's 24. Okay, a common mistake by students is when they see dm³, okay, they think it's about gases. Yeah, so read carefully, okay, and obviously it's given the concentration, so this is about aqueous solutions. And the formula triangle is for concentration mole per dm³. Okay, it's already inside the unit itself. Okay, so your top would be number of moles, okay, divided by the volume of your solution. Of course, must be in dm³. Okay, that's why I changed in dm³ in advance, okay, by dividing by 1000. Okay, yeah, so the first junction is to always go to moles. Okay, right, how did I know that I need to start from here? Okay, because for sulfuric acid, okay, the question asks you to find mole, the concentration in mole per dm³. Okay, so I know this is my ending point. Okay, so that means I must start from here. Alright, so alright, to find number of moles of sodium hydroxide, I am given volume and I given concentration. Okay, so to find number of moles is concentration times volume. So in this case, concentration times volume 0.014 mole. Okay, next we look at the mole ratio. Okay, so the coefficients in the equation represent the number of moles, okay, required for the reaction to proceed. So example, 1 mole will react with 2 moles to produce 1 and 2. Yeah, so it's mole ratio. So the mole ratio is 1:2. So if 0.014, okay, represents 2 units, what is 1 unit? So you just divide by 2 and you will get 0.007 mole. Okay, so how do we find the concentration? Okay, from moles, okay, to find concentration I need to find volume, okay, and volume is actually given. So to find the concentration is number of moles, okay, divided by the volume. So the concentration would be 0.007 divided by 0.025. Okay. Alright. And I get 0.28 mole per dm cube. Okay, and that's the answer. The answer is A. Alright. For those of you who did not convert your volumes, okay, to dm cube, you might still get the correct answer, okay, but okay, for MCQ it's fine, alright, because you don't need to show your working. But if it is for your paper 3, okay, you might lose marks, okay, because the number of moles that you calculated, okay, would be off, okay, by a factor of 1,000. Okay, you might get the correct answer, okay, but that doesn't mean that you will get your full marks. Yeah, so please convert to dm cube, okay, alright, just as a good practice, okay, for all your questions. Okay, next we have the 8th question. Okay, when sulfuric acid dissolves in water, there's an increase in temperature. When ammonium nitrate dissolves in water, there's a decrease in temperature. So obviously, this is your chemical energetics topic, okay, or otherwise known as your exothermic endothermic topic. Right, so let's do a quick revision. Okay, so for your exo, okay, reactant particles release energy. Okay, so your surrounding increase temperature. Okay, for endo thermic reactions, reactant particles gain energy and your surrounding decrease temperature. Okay, alright, so okay, we cannot measure the temperature per se, okay, of the reactant particles, okay, but we can measure the temperature of the surroundings. That's what happens to it, okay, because the reaction, okay, is a conversion of energy, okay, yeah, so we can't quite measure the temperature of the reactant particles. Alright, but we can measure the effect that the reaction has on the surroundings. Okay, yeah, so in this case, it's water. Yeah. Alright, so when I dissolve the reactant particles, okay, yeah, the water would be the surroundings. Okay, and whether it increase or decrease in temperature will determine whether it's an exo or endothermic reaction. So since sulfuric acid dissolves in water, okay, this is a exothermic reaction because there's an increase in temperature of the surroundings. But when ammonium nitrate dissolves in water, there's a decrease in temperature of the surroundings. So this is an endothermic reaction. Right, so endothermic occurs when sulfuric acid dissolves. Nope. Exothermic. Nope. When ammonium nitrate dissolves in water, the ammonium nitrate particles gain energy. Correct. Okay, so for the endothermic, the reactant particles gain energy. Okay, but for sulfuric acid, the particles gaining energy would be wrong. Yeah. Okay, for the exothermic reaction, the reactant particles should release energy. So the answer is C. Alright, next. Okay, we have rate of a reaction question. 2 test tubes. Okay, one is magnesium ribbon, and another also one is a roll, and another is a strip. Okay, yeah. So this is about your particle size. Okay, or your surface area. Okay, because all the other variables are kept constant. Okay, the concentration and volume of acid, the mass of the magnesium itself. But the difference is this is a roll and this is a strip. Okay, it is opened up. Alright, so P takes 100 seconds, but Q only takes 40 seconds, which makes sense. Okay, when you open it up, okay, alright, the reaction should proceed faster. Right, so which statement explains the observations? Okay, the acid particle for Q, the acid particles collide with the magnesium particles more frequently, which is true. Okay, yeah, so when the rate of reaction is faster, okay, therefore the time taken for a complete reaction is less. Alright, it means that the rate of effective collisions is increased. Alright, so next, let's just check for the rest. Acid particles collide with magnesium particles with more energy. No. Okay, this would only makes more sense if temperature is increased. Okay, but we assume temperature is constant. Alright, there are fewer particles of hydrochloric acid. No. Okay, because it's kept constant. There are fewer particles of magnesium exposed. Okay, if there are fewer particles of magnesium exposed, the rate of reaction, okay, would be slower, but this is faster. Yeah, so the answer is indeed A. Alright, next. Okay, I have chlorine reacting with iron 2 chloride. Okay, the equation for the reaction is shown. Okay, alright, so this one you need to see. We have iron 2. Okay, and Cl minus. Okay, but now I have FeCl3. So it's actually Fe3 plus Cl minus. Okay, so the change is from 2 plus to 3 plus. Alright, so since there is a increase in the oxidation state, okay, of iron, so therefore this is oxidized. Okay, alright, because oxidation state increases, okay, from 2 plus to 3 plus for the iron. However, okay, chlorine, okay, would be reduced, okay, because the oxidation state decreases. Okay, in the elemental state, okay, the chlorine would be oxidation state of 0, but once it forms the chloride, it becomes -1. So from 0 to -1, it is reduced. And FeCl2, once again, iron inside FeCl2 is 2 plus, then it becomes FeCl3, so Fe3 plus, the oxidation state increase from 2 plus to 3 plus. Okay, alright, since this is oxidized, okay, chlorine is the oxidizing agent. Okay, the oxidizing agent causes something to be oxidized, okay, while it itself is reduced. Same thing. Alright, chlorine is being reduced, so that means FeCl2 is the reducing agent. Okay, a reducing agent causes something else to be reduced while it itself is oxidized. Right, so yeah, I haven't even looked at the answer options. So iron 2 chloride is an oxidizing agent. Wrong. It's a reducing agent. Okay, but it itself is oxidized. C. Okay, yeah, so identify which substance is oxidized and which substance is reduced. Okay, the oxidizing agent and the reducing agent will be the counterpart. Okay, and you can solve this kind of questions. Alright, next, which statement about oxides are correct? Okay, this is under your acid-base topic, specifically your types of oxides. Alright, so we have the 4 types. Okay, just a revision. We have basic, amphoteric, acidic, and neutral. Okay, alright, and your basic and amphoteric are your metallic oxides. Okay, and this is your non-metal oxides. Yeah, so let me write notes, more notes for you guys. Okay, so the highlighted in yellow are your metal oxides. Okay, and green are your non-metal oxides. Okay, so an acidic solution of sulfur dioxide. Okay, sulfur dioxide. Sulfur is a non-metal, so it's a non-metal oxide. Okay, and okay, it will form an acidic oxide. Okay, therefore the pH is less than 7. This is true. Okay, the non-metal oxides that are neutral, there are only 3: water, carbon monoxide, and nitrogen monoxide. Okay, an aqueous solution of potassium oxide turns blue litmus paper red. Okay, potassium oxide. Okay, potassium is a metal, so potassium oxide is a metal oxide. Okay, and most likely it is basic. Okay, and basic should turn red litmus paper blue, not the other way around. So this is wrong. Okay, to extend your learning, amphoteric oxides, there are only 3. Okay, 3 metal oxides that you need to know which are amphoteric, which is lead oxide, aluminium oxide, and zinc oxide. Okay, the mnemonic that I teach my students is Lazada. Okay, the shopping app. Okay, Lazada, lead, aluminium, zinc. Okay, oxides are amphoteric. Carbon dioxide reacts with sulfuric acid to make a salt. Okay, so this is acidic and this is acidic. Okay, acidic and acidic cannot react. Okay, alright. In this one, this is basic and this is acidic. Yeah, so base can react with acid, okay, to produce a salt. Yeah, so the answer is 1 and 4. E. Okay. Alright. The 12th question, or 32 if you're taking physics chem. Okay, this is salt preparation question, and if you want to know, the answer is titration. Alright, because we have 2 aqueous solutions reacting to produce an aqueous solution. So everything is in aqueous solutions. Okay, you need titration. Right, or another way is this is a sodium salt, okay, which is a spa salt, sodium, potassium, ammonium salts. Okay, require titration to be prepared. Okay, but it's no longer in the 2024 syllabus. Alright. For question 13 or 33, okay, it's your periodic table question. Element R has 12 protons, element Q has 8 more protons, so that means element Q has 20 protons. Okay, so the question is asking about electron shells, okay, and number of electrons. Okay, so what would be good is, alright, to have the electronic configuration. So R is 12 proton number, therefore it is 282. Q is 20, So it is 2882. By the way, the 288 rule only applies up to the first 20 elements. So 21 onwards, okay, 21, 35, okay, or whatnot, okay. You cannot use the 288 rule. Okay, the 288 rule only applies up to the 20th element. Okay, in this case, it's actually calcium. Okay, so Q has more electron shells than R. Alright, first answer already. Okay, let's check the rest. Q has more electrons in the outermost shell than R. No. Okay, both has 2. Q is in a different group. Okay, so they have the same group. Okay, in this case, group 2. Okay, because they have the same number of valence electrons, or same number of electrons in the outermost shell. Are they in the same period? No. Okay. R will be in period 3 because it has 3 shells. Q will be in period 4, okay, because it has 4 shells. Alright, next question 34 or 14. Okay, which statement of bromine and iodine is correct? Okay, this is under group properties in your periodic table topic. Right, bromine is a red bound gas. Wrong. Okay, bromine is a red bound liquid that reacts with potassium iodide. Okay, yeah, this one is under your displacement. Iodine is a grey solid that reacts with potassium bromide. Okay, alright, this is okay, but this is wrong. Okay, it can be a purple vapor also actually. Okay, but okay, it doesn't react with sodium chloride. Okay, how do I know which one it reacts with what? Okay, alright, so please remember. Okay, let me write fluorine, chlorine, bromine, iodine. Okay, we also have astatine. Okay, but that is one of the rarest elements on earth, so okay, we shall not talk about it much. Okay, so reactivity decreases. Okay, and very important, more reactive can displace less reactive. Sorry, yeah, so example, fluorine can displace chlorine, bromine and iodine in their compounds. Okay, chlorine can displace bromine and iodine if they are in compounds, but chlorine cannot displace fluorine. Okay, yeah, so example, chlorine can displace sodium bromide or sodium iodide. Okay, but chlorine cannot displace sodium fluoride. Okay, so but we are looking at bromine and iodine. So bromine can displace, okay, things like sodium iodide, potassium iodide. Okay, but bromine cannot displace sodium chloride or sodium fluoride. Yeah, so yes, this is correct. Okay, therefore bromine cannot displace sodium chloride. Okay, iodine is actually at the bottom. The only one that it can displace is astatine, and as I've said, okay, is alright, astatine is one of the rarest elements on earth. Yeah, so iodine actually cannot displace, okay, the compounds of fluorine, chlorine and bromine. Yeah, so these two are out. Yeah, so the answer is B. Okay, and just a quick revision. Okay, fluorine is a pale yellow gas, chlorine is a greenish yellow gas, bromine is a red brown liquid, iodine is a purple grey solid. Alright, last few questions. Okay, we have a reactivity series question. Okay, when it comes to different metals of reactions. Okay, okay, the thing is, this question is about extraction. Okay, so very key point. The more reactive the metal, okay, the more difficult to extract. Okay, this is a very key point. Okay, a more reactive metal, okay, will form more stable compounds, so it's harder to extract them, okay, from their compounds. So I can actually change this to most reactive and least reactive. Okay, because the least reactive will be easier to extract from its compound, while the most reactive, okay, is hard, okay, the most difficult to extract from their compounds. Alright, okay, so W does not react with acids, okay, so that means it's at the bottom of the reactivity series, so it will be the least reactive. Done, good. Okay, skipping X first. Y reacts with cold water. Okay, so only the top 4 metals can react with water in the reactivity series. Yeah, so it will be the most difficult to extract. Yeah, so it will still between A and B. Next, X reacts with steam and acids but not with cold water. Okay, Z reacts slowly with acids but not with steam. Since X can react with steam but Z not with steam, okay, Z will be less reactive than X. So the answer is B. Alright, yeah. So please remember, the more reactive the metal, the more difficult to extract, okay, from their ores. Alright, next, another reactivity series question. Okay, some metals can be extracted from their ores by carbon. Ions and metals less reactive than iron can be extracted from their ores by hydrogen. Alright, so let's do your reactivity series. Okay, Popeye Sailor can make a cool zoo in the land having cute small giraffes. Okay, I repeat, Popeye Sailor can make a cool zoo in the land having cute small giraffes. Okay, alright, gonna populate with the metals in the question. Copper, lead, zinc, iron. Oh, sorry, iron. Okay. Right, some metals can be extracted from their ores by carbon. Okay, yeah, so carbon is here. Yeah, so actually, okay, all the ones below here, okay, alright, can be extracted by carbon. Alright, okay, and actually hydrogen can be used to extract the metals below it, copper, silver, gold. Alright, but okay, the question has given you, okay, more information. Alright, so actually iron and below, okay, alright, can be extracted by hydrogen. Okay, you might be wondering why. How come the metals that are above hydrogen can be extracted with hydrogen? Okay, you need to know that the reactivity series is actually done under normal conditions, okay, like room temperature. Okay, but during extraction, okay, when you heat up the reactants, alright, therefore the reactivity series might not be reflected accurately. Yeah, so need to remember, okay, the reactivity series is actually under normal conditions. Yeah, so therefore that's why although iron is above hydrogen, how come hydrogen can extract iron? Okay, yeah, because during extraction, okay, it can be used, the hydrogen might be heated up, or the reactants are heated up. Yeah, so the reactivity series might be not in the same order as the normal conditions. Okay, what do I mean by normal conditions? Okay, example, room temperature. Okay, I use acid, okay, which contains hydrogen. Okay, it cannot react with copper, silver, gold. Okay, but it can react with iron. Alright, yeah, so things like that. Okay, anyway, going back to this question. Yeah, can be extracted by carbon. Okay, copper can, calcium cannot. Okay, because calcium is above carbon. Alright, and can be extracted by hydrogen. Okay, so we need it to be lead. Alright, okay, and not zinc. Okay, because zinc is above iron. Yeah, so the answer is C. Alright, next. Okay, this is no longer in your syllabus. Which row identifies the use for the name petroleum fraction? Okay, yeah, so the answer is actually A. This is a pure memorization question, okay, which you all don't need to know anymore. Okay, question 38. Okay, this is your alkanes topic. Okay, the viscosity decreases as the number of carbon atoms in alkanes increases. Okay, this is wrong. Okay, this should increase. They are unsaturated hydrocarbons. Okay, no. Okay, unsaturated means it contains a carbon-carbon double bond. Yeah. Okay, their general formula is CnH2n plus 2, correct. Flammability decreases, correct. Okay, as you become larger, okay, it gets more difficult, okay, to burn the alkane. So the answer is 3, 4, D. Next, which statement about alcohol is correct? Okay, decolorized bromine water, this is for unsaturated. Okay, yeah, so this is no. This is for those with carbon-carbon double bond, specifically alkenes. It turns acidified potassium manganate purple. Okay, no. Alright. It's true that it can react with potassium manganate, which is an oxidizing agent. Okay, but it should be purple to colorless. Okay, alright, so can react. Okay, alcohols can react with oxidizing agents to form carboxylic acids. Okay, but it doesn't turn it to purple. It should be to colorless. Undergoes addition reaction. This one is for alkenes. Okay, addition. Undergoes oxidation with atmospheric oxygen. Correct. Okay, yeah, so example, ethanol becomes ethanoic acid. D. And last question, what is the most abundant noble gas in clean air? Yeah, so abundant noble gas. Yeah, so let's have a revision. 78%, 21%. Alright, so 78% in clean air is nitrogen, 21% is oxygen, 1% is other gases. Okay, alright, including CO2. Alright, but the other gases is mainly argon. Alright, so alright, we don't even talk about helium, krypton and xenon. Okay, yeah, so the answer is A. Right, yeah. Okay, alright, that's it. Okay, I hope you have benefited, okay, from this run through. Okay, alright, I'll see you on the next one.